Let's look at decals today. So first of all, what are decals? In essence, they are just materials which will project onto geometry or static meshes and allow you to sort of change their appearance or characteristics. So we just look at some of these decals which we do have. So here's a decal on the floor. Here's sort of a tag on a wall. This is a decal as well. So moss on a brick wall. These are like two decals together. And then you can get other kinds of effects with decals. So this as well is a decal. That blue sort of circle coming out. And this is. And they also come with some sort of built-in functions as well. So if we just look across here at this blood stain, so it can fade in and it can fade out. So we're going to look at how you can add decals and how you can create your own decals and how you can manipulate them today. So the easiest place to get hold of decals is if you go to Bridge and you just click on the Home Decals. You get a list, you got a huge sort of number of decals that you can just download as materials. So tags, concrete, damage, so as many to your heart's content. And the way that you can then add them is quite simple. So if we go and find, say, this blood stain, so just when you download it in the Megascans, you'll have this material instance. If you drag that onto the ground, into the scene, it will create a decal actor for you. And the way that decals work is that wherever they intersect with a geometry, they will project onto that geometry. So you can see the intersection box. The red arrow is the direction in which it will project. So when that projects there, you will get that kind of an effect. You can rotate them as well if you want to change the projection. So if we went here and we rotated this decal 90 degrees, and then just maybe lift it up and now intersect on this wall, you'll see that you'll get the blood stain on the wall itself. So the direction of the red arrow, so the X coordinate, is the direction in which the decal will project. So you can rotate them, you can scale them, so you can make them bigger, and you can sort of change their position accordingly. So that's one way of creating a decal. As they are materials, you can obviously just create your own decal material. So this, for instance, is a decal material. And the way that you do that is if we try to walk through an approach. So if we open an empty folder and we right click and create a material, we'll call that material decal example. We can open it. When you click on the material node itself, you go across here, you need to choose deferred decal, and if you want it to be a sort of see-through or translucent, you can also pick the translucent option, so that will give you access to the opacity. We try to maybe recreate this type of an effect. So what we'll do is we'll create a sphere mask. We'll get the world position of the pixel. We'll get the object position in world space. So that's the pixel, this is where the sphere will start. Set that to maybe 500, and then we'll just repeat that, and we'll make this one say 400. We'll subtract. Then we can give it a base color. So press 3 and left click. If we just set that to maybe white to begin with. We can put that into the base color, and we should be able to put this into the opacity. We apply, save. And once we've saved it, if we go back to our level and we take our material, which is a decal material, and just drag it onto the scene, there's nothing straight away, but if you go across you can change the size of the decal. So if we make that, should we just say 500, now we get our decal material effect. If you also look, you can sort of change the color here, but if I change it, nothing happens. So that's because we're not using certain nodes. Now we've just put directly a color in. You can right click and find decal color, use this as your node, place that inside here, apply, save, and now it's green and we can change the color of this. If you also look, there are also other options, so you can fade it in, fade it out. But if we try to use some of those, so if we say fade in duration 2 seconds, then this is the fade out duration. We can also put that at 2 seconds, but give it a 3-second delay. Then destroy after. Let's see if that works. So first of all, there's no obvious fade in on this one, and then it just disappears. So to make that work, you need to use another node in your material, and that node is called, I think, Decal Lifetime Opacity. So if you take that, and now you multiply these two together, and use that as the opacity. So if we apply, save, and if we now sort of play from here, you see how it fades in and then it fades out again. So those are two nodes that you can use in your material, in order the decal color and the decal lifetime opacity, in order to take advantage of the built-in delays and fading characteristics. So we've just dragged decal materials onto the scene to create decal actors. You can also add a decal component to an actor or another object. So if we have a quick look at that, so say we create a blueprint, we create a character, BP decal character, maybe we just give it a quick mesh, then you can sort of go to the add and you can add a decal component. You can choose your decal material. So ours was M decal example, I think we used. Now if we wanted this to be projected downwards onto the ground, as I said, the X arrow defines which way the projection happens. So we'd probably want to rotate that 90 degrees. And we can make it, just because of the size of our material, if we just make that bigger again, and compile, we drag our character onto the ground, so now that character will have this attached to it wherever it chooses to move. In our example, we could make this a lot smaller. We could just say maybe 200, 150. And it will have a smaller ring. We can create this kind of an effect where we had it was sort of pulsing in and out just by maybe taking advantage of a material parameter collection. So we go to Materials, MPC Decal, and I've done previous videos on how you can change parameters in materials, so I'll try to link to that. We'll just call this scalar radius, start off at 200. Then in our material, we check for collection parameter. We want our MPC decal that we've created, and that's our radius. So we can plug that into the outer circle. Take this, we can minus, say 50, and then plug that into here. Apply, save. In our decal character, in the graph itself, we can maybe create a timeline. Add a float track, call that radius. Hold shift and click. We can say it at 0 time it's 200, and then click again, and then maybe at 1 second it goes to 150. So from 200 to 150. When we begin, we can just have a custom event. Start. We can have another custom event. Reverse timeline. That will play here. That will play from reverse. When we get the radius, we will say set scalar parameter, material scalar parameter, choose our collection, which was the MPC decal. Our parameter was radius. This will be our value. When it's finished, we can just switch on the direction it was moving in, forward or back. If it was going to forward, we'll tell it to reverse, and if it was going backwards, we'll tell it to start. And we can just call start here. So if we play, so the one thing we wanted to do first is maybe change the length of the timeline just to the 1 second. And then if we play and we look around, so we can see that it's got this type of an effect. You notice that the decal is also affecting the skeletal mesh, which might not be something that we actually want. So you can change the settings on the mesh to prevent that. So if you go back to our character, you go to the mesh, there should be a decal. If you search for decal, there'll be the option receives decals. So if you untick that, the decal will not affect the mesh. At least that's what it should do. So if we go back here again and we look, and you see that it doesn't affect the mesh of that character. It does affect us because we haven't changed the decal value on the player character. But that's one way that you can prevent it from affecting geometry that you want to leave unaffected. Now, one thing you'll notice if you're using the Quixel materials is if you drag a new one out and you try to change the fading durations, 2 seconds, and you play, you'll notice that it doesn't work out of the box. This one does because it's been altered, but the one that we just put here will not fade in like we asked it, and it will suddenly disappear. So the reason why the Quixel material doesn't work out of the box is, let's have a look and find out why. So this is the material. We double click on that. So we have access to, there's an opacity which is by default is off, but even that, turning that on didn't make any difference. And if we go to the actual parent material, so this is the parent material, double click on that. The reason is that they are not using that lifetime opacity node, which we added in this node here, which we added in our material in order to be able to use the fade in, fade out features of the Decal component. They do use this opacity, which has an opacity intensity variable to it. So you can access this in your blueprint. So if we create a sort of bloodstain blueprint, so blueprint, actor, BP, bloodstain, open that, add a decal, and to the decal material we'll do the thing that's called blood, high velocity blood splatter. And again, if we rotate this so it's facing down, and just add that onto the ground there. Now if we go back to this, so if I just show how you can change the opacity intensity, you can then, using timelines, you can animate those changes. So if you get the decal, and if you then click and say create dynamic material instance, and this is the one, components decal create dynamic material instance. So as it says, it will allocate a new dynamic material instance, it will set its parent to the one originally set, and it will automatically assign it for you. So once you do that, you can now start trying to change the material instance properties. So you can say set scalar parameter value. The name was opacity intensity in this case, and if we just sort of put it as 0.4, we should be able to see it obviously faded. So that's what it looks like to begin with. And if we just, I just put a little delay there maybe. And if we play, so that's what it's to begin with, and then it fades when we change the parameter value. So you can access it that way. The other option would be to create a copy of this master material, and then on this opacity intensity, when you bring this out, just get that decal lifetime opacity and just multiply these two together and stick that into the opacity there. So that would also allow you to then take advantage of the built-in features. So if I just do that quickly, and if I, in our bloodstain, just disconnect this, and in the decal give it some sort of fade in duration, 2 seconds, fade out delay, 3 seconds, and fade out 2 seconds. So now this should hopefully fade in. So it fades in and then it fades out. So that's how you can use that fade in, fade out features in Quixel materials. So either access the parameter and animate it yourself, or in the master material, probably best to make a copy of that before you do that. So I'll just put it back to what it was originally. Just multiply it by the lifetime opacity and plug that in there, and that will give you access to that feature. It's also worth knowing that you can just get the decal material. You can get all those fade in, fade out values. You can also set a new decal material. You can set the decal color like we showed in our material. So if you're make sure you're using the decal color node to set that color, and then you can say set color, set decal color, and set the color there. So there's lots of ways that you can create effects and change the appearance of your decal. Again, you can also spawn a decal attached. So hopefully that explains decals, how you can use the built-in decals from Quixel, how you apply them based on their rotation, either vertically or horizontally or at any angle you would like. Also how you can create your own decal material and how you can add effects to it. And as you can see, decals can be very useful in just adding extra changes to a built-in geometry to create effects that can be faded in or faded out and manipulated.